Stealth technology, arguably one of the most significant technological advancements in military history, has undergone considerable evolution since its inception. It revolutionized the way military operations are conducted, skewing the odds of warfare subtly but dominatingly to the side that possesses it. The concept's genesis occurred during World War I, with the German military experimenting with transparent materials to lessen a plane's visibility. However, the efforts met limited success due to technological limitations of the era. The actual milestones were made a few decades later during World War II. The Germans developed a series of anti-radar materials and coatings for their U-boats and aircraft. Meanwhile, the British utilized chaff aluminum strips to disturb radar operations, a primitive yet ingenious form of radar stealth. But it was during the Cold War era when stealth technology truly began to evolve rapidly. The advancements were majorly driven by the constant arms race between the USA and the USSR. Lockheed Martin's Skunk Works division, under the leadership of Ben Rich, created the first aircraft with a specific focus on stealth characteristics, the F-117 Nighthawk. Its design and materials were chosen to reflect radar waves away or to absorb them, significantly reducing the aircraft's radar cross-section. Despite originally being an American concept, stealth technology found its way to other nations like Russia and China. The Sukhoi Su-57 and Chengdu J-20 are sophisticated stealth aircraft developed by these countries, showcasing the extent of global stealth technology evolution. In terms of significance, the impact of stealth technology is substantial. It basically revolves around the premise of, you can't hit what you can't see. Stealth technology provided an unprecedented advantage in aerial combat, enabling aircraft to carry out surveillance, bombing, or sabotage missions without detection by enemy radar systems. The consequence has been a radical transformation of military strategies worldwide. For example, the F-117 Nighthawk was instrumental in the Gulf War's success, rendering Iraq's then sophisticated air defense system impotent. However, like any technological advancement, stealth technology has its positives and negatives. On the positive side, the stealth-enabling aircraft have a significantly higher survival rate, thus reducing the risk to pilots' lives. With the technology, nations can launch precise attacks with lower chances of collateral damage. It also facilitates effective spy and reconnaissance missions without risking international tensions because the host country won't detect the intrusion easily. On the downside, stealth technology's development is incredibly costly and time-consuming, making it unaffordable for most nations. This has led to a higher wealth gap amongst countries in terms of military power. There are also arguments on the strategic risk of an undefended homeland, since a nation could deploy stealth aircraft with nuclear weapons undetected until too late. More so, the advent of stealth technology has accelerated the development of counter-stealth technologies. Modern radar systems with different frequencies, long-wavelength radars, L-band, UHF, infrared detectors, and acoustic systems are now being developed to detect stealth aircraft. This has started a cat-and-mouse chase that only contributes to increased military spending. In conclusion, stealth technology, born from the constant urge to gain an edge in warfare, has been a game-changer. Its evolution, from primitive materials trying to lessen an aircraft's visibility until now incorporating not only radar, but also infrared and acoustic stealth, shows how far we have come. While it provides tangible advantages on the battlefield, it also carries with it the potential for negative consequences that we must handle responsibly. As we embrace stealth technology's future developments, we must also remember to maintain a balance between strategic advantage and global stability.